All right, in this next example, we have some information that's being given to us. Instead of finding our mean and our standard deviation, we're actually given a mean and a standard deviation in this case, and we're being asked to answer some questions about this. So this graph shows the distribution of the amount of particulate matter or smog in the air in 333 cities in the United States in 2008 as reported by the Environmental Protection Agency, or the EPA. The mean particulate matter is 10.7 micrograms per cubic meter, and the standard deviation is 2.6 micrograms per cubic meter. Find a level of particulate matter 1 standard deviation above and 1 standard deviation below the mean. All right, so I'm just going to go ahead and label these. So for above, we're going to take our mean, right, plus our standard deviation, and then for our below, we're going to take our mean minus our standard deviation. Right? So we could, if we wanted to, write x bar plus s and x bar minus s. Not that we have to get that fancy, it's not really a formula. I'm just writing out how we're going to get these answers here. All right, so our mean is 10.7, right? We go 1 standard deviation above, we go up 2.6, so we're going to add 2.6. That gives us 13.3 micrograms per cubic meter. I'm being lazy and just writing it out using abbreviations instead of words. 1 standard deviation below our mean. Again, we start at 10.7. We subtract 2.6 this time, and we get 8.1 micrograms per cubic meter. Now we're going to use this to answer Part B. Right, so Part B says, keeping in mind that the EPA says that levels of over 15 micrograms per cubic meter are unsafe, what can we conclude about the air quality of most of the cities in this sample? Remember, most, right, ties to our standard deviation. So how I'm going to answer this question is I'm going to say, since most, again, being about 2/3 of the cities are between 8.1 and 13.3 micrograms per cubic meter, which is less than 15 micrograms per cubic meter, which is mentioned in the question. The air quality for most cities is safe. Again, this word most here, right, having to do with our standard deviation, about 2/3 should be within 1 standard deviation of our mean. So taking, instead of calculating a mean and standard deviation, taking information that was given to us and then asked to do some extra interpretation based on an additional question.